Faster than the very structure of spacetime itself, it has the power to maintain its awareness of it, and as a result, it will slowly deconstruct this idea, filling me with a sense of unease. At this moment, our night sky is rapidly changing, and within the coming decades, maybe even sooner, it could become completely unrecognizable. Experts, including Neil deGrasse Tyson, are sounding the alarm, recognizing the inevitable changes brought on by the shifting of Polaris. The background behind this change is surprisingly unexpected. Polaris, commonly known as the North Star, has been a reliable feature in the sky for ages, serving as an essential point of reference for astronomers, navigators, and stargazers alike. However, this could soon be altered, changing the way we perceive the heavens and how we study the universe. Let's examine what this transformation might mean for us. For many years, Polaris has been a guiding light for sailors and astronomers, remaining firmly positioned in the sky. Its consistent presence has been crucial for navigation, but this stability may soon be disrupted. A paper from the respected Royal Astronomical Society, published in September 2023, raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one where it could potentially explode, disappearing from sight forever and altering the sky as we know it. Before considering the possible outcomes of this event, let's look deeper into the characteristics of the star itself. Polaris is distinctive because of its proximity to the celestial North Pole. Positioned directly above Earth's northernmost point, it seems almost motionless in the sky. It resides in the Ursa Minor constellation, which is commonly known as the Little Dipper. Polaris shines with a moderate brightness, resembling a yellow-white supergiant star that is much larger and brighter than our own Sunday. However, Polaris is not just a single star. It is part of a complex triple star system, consisting of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars affect their orbits and behaviors, and disruptions in their interactions could cause shifts in their brightness or pulsation patterns. Nevertheless, the precise nature of these forces is still not entirely understood. Polaris is situated about 323 light-years from Earth, meaning the light we currently observe from it started its journey a long time ago. If Polaris were to explode, we wouldn't see the effects for more than 300 years. It's even possible that Polaris has already exploded, but we have yet to witness it. Throughout history, the North Star has held significant cultural, navigational, and symbolic meaning. Its constant position has made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in the ever-moving sky. For astronomers, Polaris has been a crucial reference point in the study of stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have offered vital insights into the properties of stars and the behavior of variable stars. This trait has also been key in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm, making its behavior easier to forecast. Recently, however, Polaris has begun to show signs of deviating from its usual behavior. This irregularity in its pulsation cycle has intrigued astronomers, prompting further investigation into the cause of these unexpected changes. Instead of adhering to its normal pattern, Polaris has started to exhibit erratic dimming, which has led to concerns that the star might be nearing the end of its life cycle. This behavior is in line with what is seen in stars that are approaching their final stages. The gradual increase in the pulsation period of Polaris, once steady, has been traced back to interactions within its star system. There has been a yearly increase of around 4.5 seconds in the pulsation period. While this may seem insignificant, it carries significant consequences. Some astronomers suggest that gravitational forces between the stars in the Polaris system could be driving these changes in its atmospheric conditions, directly influencing its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars at the end of their life cycles often exhibit such irregularities before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star nears the end of its life, it undergoes several stages, including the red giant phase, and ultimately a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium exhaustion, which is common for giant stars nearing their end. These irregularities align with patterns seen in stars nearing the end of their life cycles. However, solid evidence of an impending supernova is still uncertain, and astronomers are continuing to track these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a monumental event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain safe, regardless of whether Polaris explodes, due to its size and distance from us. While the explosion of Polaris might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. This would undoubtedly draw the attention of astronomers and observatories, generating widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. But what will happen to Polaris itself? What is its fate after a potential supernova explosion? First, it's important to note that while massive stars typically end their lives in a supernova explosion, this is not likely for Polaris. When a large star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to disintegrate. However, Polaris is not massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova, but instead, it will result in a quieter conclusion as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compressed core of a low to medium mass star that has used up its nuclear fuel. This remnant, although roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris explosion with those of actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate fates. For instance, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided important data that help us understand what might happen to Polaris in the future. For example, SN 1354 resulted in the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various frequencies, providing astronomers with a rich field of study. Moreover, SN 1987A, which was observed in the Large Magellanic Cloud, offered essential insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries can help us better understand the unique characteristics of Polaris. The formation of nebulae, like the Crab Nebula, occurs when material ejected during a supernova explosion interacts with surrounding interstellar gas and dust, enriching the gas with heavy elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the production and speed of ejected materials between Polaris's potential explosion and other observed supernova events. By examining light curves, spectra, and remnants from these events, they can make predictions about the potential explosion of Polaris. This research will help determine whether Polaris's explosion could lead to nebula formation or impact stellar distributions in significant ways. Another critical area of study involves the pulsational variability of stars that are approaching the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. The variation in pulsations in stars approaching death may indicate internal instability or an imminent catastrophic event, offering important clues about the processes that lead to supernova explosions. Despite detailed observations and research, space experts are still puzzled by the irregularities in Polaris's behavior. Understanding the causes behind these anomalies is crucial for advancing our knowledge of stellar evolution. The investigation into the factors causing Polaris's erratic pulsations requires collaboration across various scientific disciplines and the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need recalibration, which would affect the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, emphasizing the significance of this event. The mysterious behavior of Polaris highlights the need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future.